Hello, we're going to take a look at Learning Target 4.2. I can graph a linear equation by making a table, using slope-intercept form, or by finding the intercepts. And in this video, we're just going to look at part A. So we're sketching the graph of each line by making a table. So we're going to be making X, Y tables today. In step 1, in order to make our table, we're first going to need to choose at least 3 X values. Choose at least 3 X values. And when we start to make our tables, I will show you the 3 X values that I like to choose. The reason we're choosing 3, although you only need 2 points to form a line, if you make 3 points, you can double check your work and be sure that the 3 points do indeed form a straight line. Step 2, once we have our X values, we're going to plug those X values in to find the corresponding Y values. So I'm going to say plug in X values to find corresponding Y values. Plug in X values to find the corresponding Y values. And then lastly, we're going to have to plot our ordered pairs. So by choosing X values and plugging them in to find the corresponding Y values, we would have a point or an ordered pair, X comma Y. So since we are graphing, we'll have to plot the X comma Y ordered pair. I will say plot the X comma Y ordered pairs and connect points with a line. Points with a line. So we are trying to graph a line. So once we'll have some points on our graph, we will have to connect those points to form a straight line. So if we look at example 1, we are given an equation, y equals negative 3x plus 2, and this equation is in a specific form called slope-intercept form, which we have talked about. So because our equation is in y equals, this will make it quick for us to plug in X values, and out will come the corresponding Y value. So we need to start by making an XY table. I'm going to actually make my table really wide. I will show you why. The 3 X values that I like to use are -1, 0, and 1. And the reason I like to choose these 3 X values is because they are small numbers and they're easy to plug into the equation. So 0 is by far the easiest number to plug into an equation. And then I like to go 1 unit to the left of 0 and 1 unit to the right of 0. You can choose different X values, but keep in mind, the larger the number that you plug in, the greater the chance that the point could be off of your graph somewhere, and it will be harder to plot the point if it falls off of your graph. You can see that the graphs that I provided today only go 6 units in the positive and negative direction for both your X and Y axis. So you do have to be careful that you're not plugging in really large X values here, or you could get some points that are way off of your graph. Okay, so if I'm plugging X in, what this means is in my equation, and here's my equation, y equals negative 3x plus 2, I'm going to plug in this X value so that we can figure out what y equals. So my y is equal to this right here, negative 3x plus 2. But instead of writing x, I'll write parentheses. So I have negative 3x plus 2. And really I could write it for each of these, negative 3x plus 2 and negative 3x plus 2. So what I did here for y is I wrote what y equals. Y equals negative 3x plus 2, but instead of writing x, I wrote parentheses because I'm going to plug in what we're letting x equal. Here x is -1, here x is 0, and here x is 1. So now that we have plugged x in, when x is -1, 0, and 1, we can now simplify these to find the corresponding y values. You can do these in your head. Be careful if you're doing it in your head. Make sure you're very careful with the mental math when you're multiplying negatives. You can also use your calculator, but if you use your calculator, you need to type it exactly as you see it. So you would need to type -3 parentheses -1, close your parentheses, +2. Your calculator will struggle with doing order of operations if you don't type it exactly as you see it, right? Your calculator can only do what you tell it to do. So you could do this in your head. You could plug it in your calculator. When I plug in x equals -1, I get 5. When I plug in x equals 0, I get 2. And this is a quick one to check. Anything times 0 is just 0. So you're just left with the +2. And then when I plug in x equals 1, I get -1. So these are my corresponding y values. And each of these are an ordered pair or a point, -1, 5. So what I often like to do is make one last column in my table, and I like to write it as an ordered pair, so it's a little bit more clear when I go to graph it. So when x was -1, we got that y is 5. So I have -1, 5. When x was 0, y was 2. So 0, 2. And when x was 1, y was -1. So 1, -1. So now that we have our 3 ordered pairs, we need to plot these ordered pairs. This is our last step. Plot the x, y ordered pairs, and then we'll have 3 points on our graph, and we'll have to connect those points with a line. So my first ordered pair, -1, 5. So when x is -1, y is up here at 5. 0, 2, when x is 0, y is 2. And then lastly, when x is 1, y is -1, or 1, -1. And once you plot your 3 points, double check. Does it look like they will form a perfectly straight line? Meaning if you take a ruler, it's perfectly straight. If so, then you're good to go. You could connect these points with a straight line, meaning there needs to be an arrow on each end. This is a line that extends forever in both directions. If for some reason you plotted your 3 points and for some reason they did not form a perfectly straight line, then that means you made a mistake with one of your points. One of your points could be slightly off. So you might need to go to your table, double check where you plugged in your x values. Maybe you made a simple multiplication or addition mistake. So just check that because your ordered pairs have to form a straight line. One last thing that is a good idea to check, because this equation was in slope-intercept form and it was -3x plus 2, we already talked about how this -3x here is saying that we have a negative slope, and you could double check now that we've graphed it. Does it look like a negative slope? Yes, it looks like we are going downhill or we are falling down a mountain. So that is a double check for you. If you remember us talking about slope, right away we should have known that this equation will have a negative slope, and when we graphed it, we can definitely see that there is a negative slope. All right, let's look at example 2. So on example 2, I have another equation, y equals 1/2 x minus 3. It's in slope-intercept form for me. So I can start off by making my xy table. And again, I'm going to make my table really wide so that I can make that last column with the ordered pairs. The 3 x values I like to use are -1, 0, and 1. And then I'm going to plug these 3 x values in for x right here. So y equals this stuff, 1/2 x minus 3. So that's what I'm going to write here. I have 1/2 x minus 3, 1/2 x minus 3, and lastly 1/2 x minus 3. So I wrote this equation 3 times, but instead of writing my variable x, I put a big set of parentheses, knowing that I'm going to plug in 3 different x values. I'm going to plug in -1, 0, and 1. And then we do have this fraction out front, 1/2, or you can think of it as a decimal. And if you want to use your calculator to help with that, you can. But again, be careful how you type this in. This would be 1 divided by 2. You would use parentheses. for times -1, close your parentheses, -3. So if you want to use your calculator, that's fine. But again, be careful. When I plug in -1, I'm getting a decimal. I'm getting -3.5. And this is okay. And I know that on our last learning target, we tried to avoid decimals. Like we said, our slope always had to be written as a fraction. Because we are going to have to graph this, a decimal is actually easier to graph because -3.5 is halfway between -3 and -4. It's harder to graph fractions if you're trying to look at the units on your X and Y axis, and it's actually easier to try to graph -3.5. So it is okay to write decimals here, and I'm actually going to make a note. I'm going to say okay to write as a decimal. Okay to write as a decimal. And I'm just pointing this out because before I know we were always trying to write things as a fraction, but when you're making tables, decimals are kind of nice. When I plug in 0, I get -3. And then lastly, when I plug in 1, I get -2.5. So I have my X values that I picked, the corresponding Y values, and then the last column that I like to do in my table, and this last column is optional. If you can notice that this is your ordered pair, -1, comma, -3.5, and if you can go to graph that right away, that's fine. Otherwise, it might be helpful for you to write your 3 ordered pairs. I like to do that. So my first ordered pair was -1, comma, -3.5. My second ordered pair is 0, comma, -3. And my last ordered pair is 1, comma, -2.5. So now that I have my 3 ordered pairs, the last thing I need to do is plot them on my graph and connect them with a line. So when X is -1, Y is -3.5. So -3.5, again, keep in mind, -3.5 is halfway between -3 and -4. So it should be in between those two for your Y value. When X is 0, Y is -3. And lastly, when X is 1, Y is -2.5. So -2.5 would be halfway between -2 and -3. And once you have plotted your 3 points, double check that they form a straight line. And if so, you can sketch a line. Make sure you include your arrows. And we have one last example. So go ahead, flip over to example 3. And when you glance at example 3, this one looks a little bit different. The equation is not in slope-intercept form, right? This doesn't read y equals. So we need to get this to be in slope-intercept form, or else when we plug in X values, our equation isn't going to spit out what y equals. So what I'm going to do at the top of the page actually is rewrite my equation, 2x minus 5y equals -10. And this is going to be review from our previous learning target, where we need to get this equation, it's actually in what's called standard form, and we need to get it to be in slope-intercept form, or to be in y equals mx plus b. So I need to move this positive 2x over to the other side, and the way I can do that is by subtracting 2x from each side. I'll be left with -5y equals, and on the right side, again, we cannot combine these. -10 is a constant term and -2x is a variable term. So I'm going to leave them, and I'm going to choose to write my variable term in the front. So I kept the signs the same. I kept it -2x and I kept it -10, but I put my variable term, my x term, in the front, knowing that that will match y equals mx plus b. I almost have y by itself, but I have this -5 in front of it, or -5 times y. So the way I can undo that is by dividing by -5 everywhere. And then I'll be left with y equals, and I'm doing -2 divided by -5. Well, negative divided by negative turns to positive. So I have positive 2/5 x. Again, we can leave it as a fraction, especially if you're using your calculator. Your calculator can handle that fraction, 2/5. And then negative 10 divided by negative 5 gives us plus 2. So this is the equation that we need to use because it's in slope-intercept form. Y equals 2/5 x plus 2. And now we have to make our table. So sketch your XY table. I'm going to make mine again really wide. I'm using the same 3 x values. And for what y equals, here's what y equals. 2/5 x plus 2. But instead of writing the x, I'm putting parentheses. 2/5 x plus 2. 2/5 x plus 2. So I wrote my equation. But instead of writing x, I put my parentheses because now I'm going to plug in what x equals. X equals -1, 0, and 1. Here's where we need to simplify. Feel free to use your calculator. Again, just be careful how you type it into your calculator. Type it exactly as you see it. The way you can handle the fraction is this is 2 divided by 5, and you do have to put the parentheses where you see the parentheses. You do get decimals on this one. So when I plugged in -1, I got 1.6. When I plugged in 0, I got 2. And when I plugged in 1, I got 2.4. So I will be graphing some decimals here. And then my last column in my table, I like to write these as ordered pairs, x comma y. So my first ordered pair, -1 comma 1.6, 0 comma 2, and lastly 1 comma 2.4. So here are the 3 points I need to graph. So when x is -1, y is 1.6. So that means my y value is between 1 and 2, pretty much at 1.5, maybe a little bit closer to the 2 for 1.6. When x is 0, y is 2. And then lastly, when x is 1, my y is 2.4. So it's going to be between 2 and 3, a little bit closer to the 2. They form a straight line, so I can connect them with a line with arrows on both ends, showing that it does extend forever in both directions. And I'm good to go. At this time, you have 2 U-tries to do, and you'll see that one of them, actually the second one, is already in slope-intercept form for you. However, the first U-try, you're going to have to do some work to get it in slope-intercept form. So at this time, go ahead, pause the video, and see what you come up with for these U-tries. Let's see how you did. On the first U-try, my equation was not in slope-intercept form. So here's my work getting my equation to be in slope-intercept form. So the equation that you should have been creating your table from is y equals 3/2x plus 2. I picked my 3x values. I wrote what y equals, except for instead of writing x, I plugged in the -1, 0, and 1. And you can see here the 3 ordered pairs that I got. When I graphed them, they ended up forming a straight line. And then for the last U-try, this one was easier because my equation was already in my slope-intercept form. So this means right away I can choose my 3x values, and then this is what y equals. Be very careful, make sure you didn't miss this negative sign, -1/2. So here I was writing -1/2 x minus 1 for each of these equations for what y equals. And instead of writing x, again, I put parentheses, plugged in the 3x values that I chose, and then here were the ordered pairs that I got. So you had to be careful once again, graphing decimals, and here's what your graph should have looked like.